Hello viewers, hello physics lovers. In this video, I'm gonna solve for you the questions of Pulley block system and the questions that are connected with some strings, tensions and block systems like that. So we know that tension is some kind of a force that always act away from the body. Let's say that we have um, a block here, suppose, and here's a string connected. Suppose there's a mass m and the string is connected. Now if I pull this, so the tension always acts away from the body. If I pull this, if here's a body of mass m and here's a string attached and I'm pulling it upwards, so the tension force is also upwards. If I'm pulling it downwards, the tension force is also downwards. So it's not basically it is upwards or downwards or right or left. The tension force is always away from the body. Tension force always acts away from the body. So there's a basic information that tension is always acts away from the body. Now in this video, let's we have to deal with this kind of system. Like this is a system, as a pulley system. There is a block of mass m here and another block of mass m here, right? Suppose this is m1 and this is block is m2 mass, and the tension is always away from the body. So here's the tension. And remember one thing, that in this type of questions there are some assumptions that we have to take in order to proceed in the numericals. The assumptions are, the first of all, the string is massless. The string is massless, so there is no mass in this string. Second, string is inextensible. My handwriting, I know my handwriting is not that good, but inextensible means you cannot stretch the string. If you stretch the string, it will break, because the amount of tension force that it will uphold is maximum for it. So the tension, if you apply a stretching force, if you apply a force, suppose you're fix this mass and you're pulling this m2 downwards, so this might break. This might not actually it will not stretch, because we have that assumption that string is inextensible. So if you're pulling it downwards and keeping this fixed, so the string will break. So this is two basic assumptions: that the string is massless, no mass in the string, and second is the string is inextensible. So now in this type of question, there are two types of question that can be asked. Number one is what is the acceleration of each block? What is the acceleration of each block? What is the acceleration? Now suppose, let here m2 is greater than m1, so downward force is m2g and here it is m1g. So since m2 greater than m1, so we know that this block will go downwards and this will go upwards. So and since the string is same, so the accelerations for the both blocks will be same because the pulley is fixed. For the fixed pulley, this is a fixed pulley, right? This is a fixed pulley. This is not a movable pulley, this is a fixed pulley, and this is attached from the ceiling. So the acceleration, say here's downwards is a and upwards is also a, right? So it is going downwards a and this mass is going upwards a. So for this I can actually write the equations, like for this m2 block, for equations for m2 is down, it is going downwards, so the downward force is greater, so m2g, and upward force is t, that is minus t, and that is mass m2 into acceleration a. That is the second law of Newton force. That is F net equals to ma. Are you seeing this? Yes, F net equals to ma. So what is the F net here? The F net here is basically for this block the downward force minus the upward force. Because why? Because this force is greater, because this is going downwards. So this force is greater, that's why it is going downwards. So m2g minus t equals to m2 into a. It is for m2. And for m1 we can say this is going upwards with an acceleration a, so upward force will be greater, that is t minus m1g equals to m1a. And if you solve these two equations, if you solve these two equations then you will get the value of acceleration. Now simply by, if you add these two equations, these are simultaneous equations, so if you just add this, so let's take what happened. So okay, so we are getting the equations here. The equations are m2g minus t equals to m2a, and t minus, because it's going upwards, for m1g equals to m1a. So plus, add these two equations, so you will get this t cancel, so m2g minus m1g equals to m2a plus m1a. Now you can take common a from here, so m2g minus m1g equals to a into common m1 plus m2. So if you divide this by m1 plus m2, you will get a equals to m2g minus m1g divided by m1 plus m2. So that is the acceleration with which the two of the blocks will move upwards and downwards. This is this acceleration for each block. Why each block? Because the pulley is fixed. The pulley is fixed, that's why it is m2g minus m1g divided by m1 plus m2. That's why it is the acceleration for both blocks same, because the pulley is fixed. Very important words, guys, very important words. Number two, we need to find the tension force. So just by let's say this is equation 1 and this is equation 2. So if you put the value of a in the equation 1, suppose, you can also do in equation 2 as well. So if you put the values of a, so let's say putting a in 1, equation 1, so you will get m2g minus t equals to m2 into a. Now what is a? This is a, right? So m2 into a. So m2g minus m1g divided by m1 plus m2. Right? Right? Sorry, we have a problem here with my camera. Yeah. So here we go. Sorry guys, I'm shooting this with my phone, so that's why it's a problem occurring here. So you see that m2g minus t equals to m2 into m2g minus m1g by, so solve it. m2g minus t equals to m2 square of g minus m1 m2g divided by m1 plus m2. So if you want the value of t, this will go here, m2g will go rightwards, and so we gonna have m2g minus of m2 square g minus m1 m2g divided by m1 plus m2. So multiply with this, so t equals to m1 m2g plus m2 square g minus of m2 square g minus m1 m2g, and divided by m1 plus m2. So m2 square g plus minus are cancelling, plus m2 square g and minus m2 square g is cancelling, and we are getting here. Oh, sorry, there's a mistake that I have done. This, if the minus goes in, so this will become plus. Yes guys, so the tension force is 2m1. This is m1 m2g plus m1 m2g, so 2m1 m2g divided by m1 plus m2. So this is a simple question. This is a simple question, right? This is a simple question. This is the tension force and this is the acceleration, and tension also remains same for the each blocks because the string is same. This is very important guys. So this kind of question that you may be faced in your exams, you don't know how to solve it. So this kind of question, this is a basically easy question. Now let us take some tough question guys. Let us take some good questions. So let us take a question like, suppose there is a ceiling and there is a fixed pulley. Again guys, there is a fixed pulley, and a mass is hanging from here, and another string, this string here is connected with a man. Sorry, I'm drawing this drawing. I know this drawing is not good, but this is a man, or you can take also woman. So man or woman, there's a person here holding this string and pulling it. Now this pulling it, so the tension force also here is T, and the tension force is T, because I know whatever, if there is a man or there is a car or any kind of object, the tension force always remain the same, the T, because tension force does not change with, you know, if you change the objects, because if the string is same, the tension will be same. Now in this question we have given values, some given data that this man has a mass of q kg. This man has a mass of q kg. So vertically downwards will be qg newtons, right? Vertically downwards is qg newtons, and this the question is a man of weight q. So there's a man of weight q and is standing on a horizontal plane with an inextensible rope. Again guys, this string is inextensible. Why I am taking this particular question? Because this man is pulling this string downwards, but the string does not changing its length. Inextensible means the length change is 0. There is no length. Suppose the initial length is L, and afterwards also if we pull, the length also remains same, that is L. So there is no change in length. Delta L is 0, right? So that is what I'm talking about in the previous question. That is, if you pull it downwards, the string will not change its length. So the question proceeds with there is a tension force T, and this block has mass of this mass is P. So vertically downwards is P times G. We know G is the acceleration due to gravity. So this is this much newtons, PG. So now the question is, what force is exerted by the man on the horizontal plane? So what the force? Find the force F. What is the force? Find the force which the man exerted on the floor. What is the force that is exerted by this man on the floor? So let's solve this problem. So according to this figure, this force is greater, right? Why? Because he's pulling it downwards. So Q and the tension always, the tension, we also say that this tension, we have to calculate the force exerted by this man. So let us consider this man. So the man is pulling it downwards. So the force is QG minus T. Why? Because this force is greater than this force. So QG minus T for this man. And the question also says that this is a smooth pulley. That means the friction coefficient is 0 for this pulley. There is no frictional force here. And the question is saying that over a smooth pulley is fixed, and so that the fall of a body of weight P attached to the other end with the rope is prevented. So guys, the question is basically not just the force, what is the force acting on the floor due to this man. There's also a condition given that this block is not falling. So what is the force with which the man has to pull the string so that this block will not fall to the ground? So QG minus T is for the man, and let us take for this P block, and for this P block the net force is T minus PG. Why T minus PG? Because he's pulling it downwards and it is going upwards, so the tension force will be greater. Now since the block is not falling, here's the question states that the fall of the body of weight P attached to the other end of the rope is prevented. So the block will not fall down, such that the man pulling it downwards, and this force exerted on the floor due to this man is not allowing this block to fall down on the floor. So that means these two net forces should be equal, so that it will not fall, so that this P block will not fall to the ground. So let us calculate what is the value of T. So the value comes out to be P plus Q by 2 into G, right? This is newtons. This is the tension force. This is the tension force. What is the tension force? P plus Q by 2 into G. So this is the force. This is the tension force. And what is the force that is exerted by the man? So the force exerted by the man is, what is the force? Simply put the value of T in this equation. So QG minus T. What is T? T is P plus Q by 2 into G. And this is the force, guys, which is here exerted on the floor due to this man's weight. So let us simplify this. So you get QG minus PG plus QG, and there is a 2Q, so 2 is here, and divided by 2. So this 2 is 2QG plus QG. What is the force, guys? If you simplify this, QG minus P plus Q by 2 into G, so this is 2QG minus PQ plus QG divided by 2. Oh, sorry, so this is a minus here, minus going here, so this is QG, so this is QG minus PG, QG minus PG by 2. This is the force, guys. And if you take G common, so G common, Q minus P divided by 2, Q minus P divided by 2. This is the force. This is the force exerted by the man on the floor, exerted on the floor. So hope, guys, you understand it clearly that this smooth, there's a question here, the man is pulling it downwards, so it's going upwards, but also at the same time it is preventing the man's weight, preventing its motion, preventing it to fall down on the floor. So that's why I equate this to net forces to get the value of T. And if we put the value of this into this equation for the man, that is QG minus T, so if you put the value of tension, you will get the force exerted by the man on the floor. So let us take another good question. question number 3, guys. Question number 3. So the question number 3 is, let us take some good questions again. So guys, here's a question. So there's a ceiling here. There's a ceiling, and there is a mass. There's a massless pulley, and here is a mass of value m1, and there is another mass of value m2. So tension force here is T. Tension force is T. Now the m1, the given in the question, we have given that m1 is 12 kg and m2 is 8 kg. So since the string is same and the pulley is fixed pulley, so we know that this will go down with a value of 12g, and this will, the downward force is 8g. So since this 12g is greater than this 8g, so it will, the m1 block will move downwards with a value of a, and with a value up with a also for this m2. Now similarly, guys, again, like the first question, the very first question of the video, we can say that for this, let us take the FBD. Let us take the FBD, the free body diagram of M1. So this is M1, this is downwards 12G, upward is tension force T, downwards is A. So for this, and M1 has a value of 12. So net force 12G, because it is going downwards, minus T equals to 12 into A. Newton's second law of motion, that is net force equals to mass into acceleration. Net force is 12G minus T, and mass into acceleration 12 into A. This is the first question, guys. This is the first equation, sorry. And the second equation for this, let us take this M2. Let us take the FBD for M2. This is M2 with a value of 8. So downwards is 8G, upward away from the body is tension T, and it is going upwards with value A. So tension force will be greater because the net acceleration is upwards. So T minus 8G equals to 8A. Now guys, solve these equations. Just simply add this equation, get the value of acceleration A, then put the value of acceleration in any of these two equations to gain the value, to obtain the value of tension. So I'm leaving this for you to calculate. Let us take the fourth question. The fourth question, let us take. Now we are getting some questions that is very difficult, right? We solved this kind of questions earlier also. Now I'm going to solve good questions, like what if there is friction present? What if friction present? What if friction present between the surfaces? In the pulley system, what happens when the friction force starting to appear? What happened? Guys, let me tell you, friction force is a self-adjusting force. friction is a self-adjusting force. What does it mean that is self-adjusting? Friction changes its value according to the situation. Frictional force changes its value according to the situations, according to the system. Let's suppose that we have a block here with mass m, and there is a tension here applying, and the friction coefficient here is mu. Between this block and this horizontal surface, there is a coefficient of friction that is mu. Now, can we say that this block will move? This block will move or may not move. So what are the conditions to move this block? So understand, there is a vertically downward force mg, and there is a normal force that is n, right, for this body. And we know that since this body is in equilibrium position, this in rest or in equilibrium position, we know that n equals to mg. So then what is the frictional force that is in the direction, in this direction? What is the frictional force? The frictional force is mu times n. Mu, coefficient of friction, times n, normal reaction. So it will be mu mg. Now guys, if T is greater than mu mg, the block will move. The block will move from its position. That means it gains some acceleration. In this direction, the block will move if T is greater than mu mg. Second, if T is less than mu mg, the block will stays at rest. Whoa guys, the block will at rest. Acceleration is 0 in this case. That's why it is at rest, because the frictional force here, that is mu times n, is cancelling this force tension. So that why there is no net force on the system. There is no net force on the system. That means if we, let's say it is going here, so net force T minus mu n equals to mass into acceleration is 0. Acceleration is 0. So T equals to mu n. That's why these two forces are equal and opposite, because friction always opposes the relative motion. Friction always opposes the relative motion between the two surfaces, or between the contact surfaces of two bodies. Now, self-adjusting means that there is two types of friction forces. One is simply static friction. One is static friction force. Now, what is a static friction force? In this case, the block is at rest, so the friction in this case is static friction force. If the body is at rest, there is no relative motion. There is no relative motion. So that where the static friction comes into play, comes into the frame. If a body is at rest, but friction is present, but we are applying a force like this, we are applying a force F this direction, we're pulling it with a force of tension F equals to T, we're pulling it, but no matter what the force is, this block is not moving from its position. That means there is some force that is opposing this force and opposing the relative motion between these two surfaces, and that is the static friction, guys. This is the static friction. And if the static friction, that is, we denote this by mu s, if the static friction coefficient, this is the coefficient of static friction, and the mu times n, we call this as the static friction force. Static friction force, right? So this is a static friction force, mu s n. Now guys, very important, now if this static friction force reaches its limiting value, if mu s n reaches its limiting value means its maximum value, then this will change into kinetic friction, kinetic force of friction. So understand this, if we are applying this T force and there is a backward mu s n, so why this is not moving? Because T equals to mu s n, T equals to mu s n, so that why is not moving. If T is greater than mu s n, T is greater than mu s n, we can say that mg is as n. So if T is greater than mu s n and it crosses, and the tension force crosses its maximum value of the static friction force, the block will simply move with an acceleration. It will simply move with a acceleration in the direction in which the force has been applied externally on the body. So if I say that this force is greater than this force, so this will accelerate. But guys, very important, we all have this kind of assumptions in our mind, or this, you can say, this type of things, that the friction force has formula that is mu mg. No, friction force has no formula set as mu mg. If your physics teacher is saying you that the friction force is mu mg, then they're saying wrong. And why? I will clear that to you guys. Now let us take an example in which the friction force is present in the pulley system. Simply let us take that there is an surface, and this is a rough surface, guys. So rough means there is some friction coefficient present. This is a rough surface, and there is a block here that is of mass m, and there is a pulley which is attached with this block with a string, and a block is hanging downwards with, let us take, this is a table, right? And there's a block of mass small m is hanging, and the friction coefficient between this block and this surface is mu. Now we have to we know that tension is T here and the tension is T here, but we don't know that if this system is going downwards, or if there is any motion happening between these two blocks, because there is now friction present, because friction is present, because downwards is mg, and because this mg is hanging, so in common sense you can say that this block will slide down and will gain an acceleration. But guys, let me check that if this friction force is greater than the force, there is tension. If that is happening, then this block will not move and there is no acceleration of this block. So if I say this block is moving with an acceleration a, and since the string is same, so this will also go down with an acceleration a. So what is the friction force that is acting here? This friction force is kinetic friction force. The very moment the body starts moving, the very moment this body starts moving from its position, the kinetic friction comes into the frame. So backward force is what? For this, let us take this mass m and draw its free body diagram. So this is a mass m, and the the vertical downwards is mg and upwards is normal reaction. So the frictional force is mu times n, and here n is equals to mg, so we can say mu mg, and that is, guys, the kinetic friction. This is the kinetic friction. Why this is kinetic friction? Because the body is moving. So backward is mu mg, and here the tension and the net acceleration is here. So for this block we can say that the equation for capital M mass is T minus mu mg equals to ma. Wow, now we are getting some different equations because now friction is present. So T minus mu mg equals to ma, because this tension force is greater than this force, and that's why it will gain some acceleration in this direction. So this is an equation 1. And for this, simply this is m, this small block that is hanging, we can say equation for small m, that is mg minus t equals to ma. Now guys, simply solve this or simply add this. Let's say 1 plus 2. If you solve this, so we'll get tt cancelling. So mg minus mu mg equals to m plus m a. So the acceleration here, mg minus mu mg, sorry, it is capital M, mu mg is m plus m. So this is the acceleration, guys. This is the acceleration. Now we have to find the tension. Now tension is T minus, simply put this acceleration in equation 1, from 1, putting this in 1. So T minus mu mg, T minus mu mg is equals to m into a, that is mg minus mu mg divided by m plus m. So T minus mu mg equals to, over here, mmg minus mu m square g divided by m plus m. and this is going here with plus, so mmg minus mu m square capital G plus the mu m square G plus mu G divided by m plus m. This is just mathematics, simple mathematics. So this and this will cancel, and from here we can get the value of tension. That is T. From here we say that mmg plus mu mmg divided by m plus m. So guys, the tension force here is, if we simply common the mmg part, so we get mu plus 1 divided by m plus m. This is the tension force, guys. This is the tension force. So hope you understand how to handle this type of questions. Now what if this is question number 5. What if here's an inclined plane with an inclination of theta, and there is a mass m, and there is a pulley here, and there is another mass is downward that is hanging with a small m. Now in this case we have to find this tension, and I don't know, we have to find the tension and the acceleration. Please pause the video and try to solve on your own. This is a very good question, guys. And the friction coefficient between this rough plane and this block of mass capital M, say this is mu. The friction coefficient here is mu, and this is simply hanging, and this is not contact with this surface, so this simply is mu. The friction coefficient is mu. So we have to find what is the tension force and what is the acceleration force. What is the acceleration of these blocks? Now guys, we understand what is static friction, what is kinetic friction, and all these sorts of things. But now we have a very important question here, that what will be the direction of the motion? If it is going downward, this is going upward, or this is going downward, this is going upward, or both blocks stays at rest. We don't know. So simply take this M block and try to draw a free body diagram. So this is a angle theta, suppose say, and there is a mass block of M. So vertically downwards, understand this, vertically downwards is mg, and normally there is a normal reaction force. The normal reaction force is always perpendicular to the surface. If this is the surface, suppose this is normal reaction force, the surface is this, the surface is this. If the surface is horizontal, the normal reaction force also perpendicular, that is vertically upwards. So it depends, the normal reaction force depends on the surface, on the orientation of the surface. So normal reaction force depends on the orientation of the surface. So this is the surface slanting with an inclination theta, so this is n. Now let us draw, let us try to understand this angle, this is, we have to find the components of mg. So here's again I am drawing this vertically downwards mg. This is normal reaction force upwards, and here's the part, and this is, if you see this, if I guys, we have a problem here because the paper is so small. So cut this and we'll draw this part again. So this is M, and the inclination is theta, right? Inclination is theta, M. This is vertically down mg. This is N. So if this angle is 90, this angle is 90 minus theta, because this angle is theta. So this angle is theta. So the component of mg, the component of mg here is mg cos theta, and along the incline, that is mg sine theta, right? So let's change the paper and try to understand what is happening. Guys, this is a very important question. So this is the question. Here, this is a block of mass M, and this mass with a rope of mass small m. So here is tension, here is tension. The vertically downward force is mg sine theta. The vertical, along the incline, that is mg sine theta, and there is a frictional coefficient mu. So the frictional coefficient is mu is here. So if the motion is here downwards with an acceleration a, and this is going up with an acceleration a, so the friction force, what will be the direction of the friction force? It will go this direction, so friction force will act this direction. Always understand, the friction force always acts on the opposite to the direction of the motion of an object. So this is going up, so this is friction force, this is Fk, kinetic friction, that is mu mg. So for this M block, equation for M, that is there is mass M, this is tension T, this is mg sine theta, this is Fk, that is mu mg, Fk, and the net force, this net acceleration is here. So T minus mg sine theta plus mu mg equals to ma is equation 1. And for this is going downwards, and the downward force is mg, so equation for small m, mg minus t equals to ma. Now this is 1, this is 2. Again guys, just simply add these equations and find what is the tension and what is the acceleration. Let me solve you for this. First add this, so this dt will cancel, so we will get here mg minus mg sine theta plus mu mg equals to m plus m into a. So mg minus mg sine theta plus mu mg divided by m plus m equals to acceleration. This is the acceleration guys, with which the two blocks will move. This is going downwards, this is going upwards. Now simply in this question we can also say that if this is going downwards, so this upward acceleration, this is downward acceleration, the friction force will be this word. So it depends on the nature of the motion, on the direction of the motion. In this same question, if the acceleration is downwards, the friction force will be there. So this type of this is how you can handle, and this acceleration you put in this, you get the value of t. So this is how you can solve this kind of problems in inclination. And always remember, along the incline this is always mg sine theta, and the normal reaction force is, in this case, is mg cos theta. Yes, that's why this problem that I have solved is wrong, because now this is not mu mg, the friction force is not mu mg. The friction force is mu mg cos theta. The friction force is mu mg cos theta. And why this is mu mg cos theta? Let's check it out. I told you that friction force is a self-adjusting force. It depends on the orientation on the system. It depends on various types of aspects. So in this question there's an inclined plane, right? So there's the angle theta, so there's a block of mass m, and vertically downward that is mg, and this is the normal reaction force perpendicular, and this angle is 90 degree, so this angle is 90 minus theta, and this is the component that is theta, because this is 90 minus theta, so this is theta, and mg is this part, component is mg cos theta, mg cos theta. Now since this is in rest, so n equals to mg cos theta. So the friction force, whether it is in this direction or in this direction, the friction force is mu times n, and that is mu mg cos theta. So for this our equations become like, if this is going, so mg sine theta minus mu mg cos theta, so mg sine theta plus mu mg cos theta. This is the net force in this direction, and this is going upwards, so that's why it is t minus of this into mass into acceleration, mass into acceleration. This is the equation, and this is equation for m. Right guys, hope you're understanding this. Look at this here, what I have done here. We have taken, this is mu mg, no, this is not mu mg, this is mu mg cos theta, because now it is on an inclined plane. So according to normal reaction force, exactly mg cos theta, so mu times n, so mu mg cos theta, and equation for small m, this will remain same, that is mg minus t equals to ma, and this equation 2. And now solve this, get the value of tension, get the value of acceleration. Hope you understand, guys. Thank you for this lecture.